So hi, this is Shivam. This is the second video of the series of the tutorial I'm going to make about MATLAB Simulink. So, so this is the basic thing you need to know before going start making model of quarter car or half car model. So let's suppose this is a road emulation. So from the pump, the displacement is going to transfer and the force is going to transfer through wheel to the sprung mass of the body. So suppose the displacement y is there uh, on the tire, and similarly the thing we need is the amount of displacement of the sprung mass, that is m, that is x here. So now the the spring and dampers of the system is make the spring has stiffness k and the dampers have a damping coefficient of value c or variable c. So we will now going to make a mathematical model of this. So the general mathematical model is mx double dot plus kx plus cx double dot. But here the displacement, our total displacement is x minus y. So it will be x double dot plus k to x minus y plus c into x dot minus y equals to 0. Now our main objective is to shift the equation in form of x double dot. So we can proceed with the variable x double dot. So we'll going to shift the two terms on the right hand side. So it will be k into y minus x plus c into y dot minus x dot. Now we're going to shift the sprung marks to the right hand side. So the equation will be 1 by m. Uh, in bracket it will be k into y minus x plus c into y dot minus x dot. Now we will going to use this equation to uh, use it in the Simulink, and we will going to see the further steps. So now while shifting it to the Simulink, further things need to be considered. So now this is the basic model that we uh, decided upon. So the load input is y, our slug master displacement is x with a spring of a spring coefficient k and damping coefficient of c. Now we will just going to rewrite that equation in the same form that we have derived through the mathematical model. So it will be k x double dot plus 1 by m k into y minus x plus c into y dot minus x dot. Now before going further, we need to, for the sample calculation, decide some value of k, c and m and the road input that we are going to provide. So the road input can be of many types, so I'm going to make a video about that also. Could be many like sine, half sinusoidal, step and many more. So now we'll assume that our mass is 500 kg and damping coefficient will be 25,000 Newton per meter, and sorry, the stiffness coefficient of 2000 Newton per meter and damping coefficient of 1000 Newton second per meter. Now we will basically design a loop kind of thing so that it can be run through a Simulink model. So we just have one input. So we will try to make use of it using like this is the basic thing that is going to be used further for the quarter car. So let's first start with the input that we have. So we have that input y and our output is x. So for the designing, firstly we will assume that here is the input y and this is our output x. Now what we will going to do is we will deploy a function through which it can be subtracted. So this function is available on Simulink. So using this function, the output of this is going to be y minus s, and similarly we will uh, we will do it in part form. So one part is going to be applied with k, and other is firstly going to be derivated and then into then going to be multiplied with c. So it will be c into y dot x dot. Now again we are going to add this value, so the output will be our so the output will be this value k into y minus x plus c into y dot minus x dot. Now we will further multiply it with 1 by m, so this output, so here it will be x double dot. So now we can multiply it, we will going to integrate this x double dot, so it can be become so it will become x dot, and again after integrating it, it will become x. So that also can be done using integrating function in MATLAB. So firstly 1 by s, then it will be x dot, and again 1 by s, it will be x. So this and this will be same. So as you can see, there is a loop kind of thing. We just give it one input and we are getting an output. This is the basic thing that you need to understand to go further for the quarter car or different car models. So now what we're going to do is we will try to do it in Simulink. My system is little slow. So firstly we will start with the input. So this window appears after clicking this button that is available. This is the library browser. You should click it. Now we have different option like continuous, commonly used blocks. Most common blocks are in it only. So basic thing that we use like scope for the output for some, and this can also be used for subtraction and integration, and this is like for common things for derivation and integration. Like there are many tools that can be used. So this is basically for different type of sources that are there, uh, like input. So for first trial purpose, we are going to use a step input. Now for different type of input, as I said, I will going to make another video. So we will mostly use a step input. This is our Y. So it can be like deployed using this drag, and you just press drag it there and leave the left mouse click and it will be here. Okay, so now we will deploy the sum. uh, so now we will drag and drop other things like we do need a derivator for this. We need an integrator. uh, Other things can be found in step blocks. We need a sum, and for seeing the output we need a scope. My system. Yeah, so we had the basic thing. So we will firstly start with our step, and then this is you can change the name to this. So we will start firstly. This is our step, that is our Y. Now we will going to add, and there will be our output. So we will starting with our input, that is Y, and then we will going to do the further step. So now first thing we need a gainer too. Gainer is a basically to multiply things. So after we'll just make a structure of it fastly. System. So so this scope is our output. So uh, my system is ready. So this is the differentiator. So what will it do is after so this is our x. So I will put it like this. I will change this plus value to negative. So it will be y minus x at this line. Now this line will go in two direction. This is our k, and using this it will going to derivate. So this yeah. So now this is our first gainer. This is the second gainer. So this is the second gainer. It will be connected with this line. So now we do need, so we can copy just clicking control and right click, so it will make a copy of it. We can connect this. So we do need another gainer here for 1 by n value. We'll connect it through here to this. So to add this we need another, so you can delete if you made extra copy using delete button. So at this it will going to add these two values. So we can just connect it here. We need another indicator here. So this is our scope that will give us the output. Then we can connect it. So yeah, so this is our basic structure. We will just finish it up fast. So this line is our x, and so this value, if you double click it, it will show the pop-up showing its value. So if you change this to minus, so it will be subtracting this. So this will be now y minus x. And this line is y, this will be y minus x, and this is our k. So either you can put a variable and give it input from code 2, but we will do that later. Firstly, I'm just going to put the value here, that is 2500. This is our k. This value is k. So as you can see, this value is inputted. You can also change its size. So this is k. As you can see the value, double click it, the pop-up is show. Oh, you can change the name to, you can write it k. Now this y is going to multiply with k, and this will be k into y minus x, and similarly after get derivated here, it will be y minus dot. It will be y dot minus x dot, and it is c, so we will put the value as 1000. Okay. As you can see, this is c. So this, after getting added these two values, this will be our half equation, and we will going to multiply this 1 by m. So 1 divided by value of m, that is 500. Okay, so this is 1 by m. Then this is our x double dot. This is our x double. After integrate it will be x dot, and again integration it will be x. And we will firstly give it a step value, step time of 0, and initial value will be 2. We can, okay, so we can also check like how the step is performing by giving input. So we will just put run. After run, you can see, like double click on the scope, and then if you double click on scope, it will show you the required output. This is running. It doesn't take that much of time if you go fastly or your system is fast. So in my case, the system is a bit slow. So this process is very useful. Like if you, as you can see, we just give it a one input, and using that input, it is going through a loop. So if like it is very hard to integrate such kind of equation. Firstly, you need to make it an algebraic form, and then run it. These kinds of technique are also very useful in optimization purpose. So after this, I will make a video about firstly the quarter car, how this concept is elevated. And that side, similarly, it can be done for half car, and similarly also for full car. The basic is same, just the extent of it increases. So if you wanna see that also, do subscribe. So loading. I will pause it for a minute. Compiling is about to finish. So basically it's like a code. You can also give input using a code too. Yeah, so we started. So now, as we have put it for run and we have provided step input, so the scope is showing like from 0 it goes up, and then as damping is there, it damps out. Okay, so now you can check how like the input was. Just click control and there is an input scope here. You can always uh, whatever, whenever you need to see what thing is doing what, just get a scope and check yourself and you will find it. So you can play with it, you can provide different values and how system is working, you can check accordingly. So it's quite fun actually. So now the as it's a step input, it will be generally like you at fixed time frame. How what is the input like? Suppose this is the road. Okay, so in our case, it's like there is just a step. So wheel is going and there is step. So another, there are different like single bump, or if in case of half car when there is two wheel, we can give input as one bump, two bump. It can be done on this too. So this is very useful just in case when you are trying to simulate the basic working. As stamping is there. So just double click on it. As you can see, the step is 1 and step time is 1 and the final value is 1 and initial value we have 1. Sorry, initial we have 2. Just double click on group. So it was like we have initial value of 2 and there was a sudden drop like a basically a step or in Hindi you call it CD. Okay, basically step or ladder kind of system. You can change it like if you want the final value for step up, you can go to put initial value of the input. Firstly we are going to provide an initial value of 0 and then final value of 2 and the step time of 1 second. So this is how it's looking. At 1 second we are given a bump of 2, so it's like a straight road with a bump of 2. So as it's a bump, so as soon as the bump of 2 is given to the wheel, now firstly it goes up and because of the stiffness and dampers that are there, it damped out to around 7 seconds. The times can be adjusted accordingly. So there are various tools in it. Like you can explore various tools are also there. So this is the basic gist of it, how it generally works from input to output, and using this concept only we are going to furthermore develop it, firstly for quarter car, then half car, and accordingly full car. So the time, as you can see, so it's opening. So there are various things in output block too. Like if you want to check when it's damped out at what second, and different values that are getting are on output block of that scope. So so this is the model explorer, and this is that. So using this setting, you can configure the parameters like from how much time it's going to, like if you want it to run like we can also run it for only 5 seconds. It's up to us. So and the output parameters can be checked by this tool only. You just need to go to configure parameters, and there are various things in tool also. So you can, like, these are the different option available. Then like as you can see, the base run is for 10 seconds. Then there are other tools also in here that can be further used to find like where at one point it's completely damped down. So that's all for this video. Hope you understand it, and to watch my next video that is on quarter car. And if you have anything you specifically want to know about MATLAB or any other software, also do comment. Thank you.